Good day, everybody. I hope you're doing great. We're going to discuss today normal distribution. By definition, it is a continuous, symmetric bell-shaped distribution of variable. It is a function that represents the distribution of many random variables as a symmetrical bell-shaped graph. For example, in our time, we have this pandemic. We want to know the number of patients or the probability of infected patient in terms of age, for example, 30 to 40. You want to know. Therefore, the best tool here or one of the best tool is by normal distribution. Let's go now with the properties of a normal distribution. For one, a normal distribution is a mathematical model represented by a bell-shaped curve which is symmetric with respect to the mean. For example, you have this number of household, and we are talking here of their income. When we say normal distribution, most of the respondents here are having average income. If the average income is 15,000, most of the respondents in certain barangay, we have here 15,000. There are few numbers of family having low income or below 15,000, and there are also few having above 15,000. The normal curve does not intersect or touch the horizontal axis. Now, in any way, as we go to the right side or going to the left side, it will not touch the x-axis. The mean, the median, and the mode, if it is equal, therefore we have a normally distributed data as shown in the presentation. And the total area under the normal curve is 1. The other half is 50% or 0.5, and the other one is 0.5. As you can see, this is an example of a standard normal distribution, whereas we are going to use the z-score. The z, which is 0, is on the middle, and going to the right, it is +1 or +1, and so on and so forth. And on the left, it is negative. Now, if we have this example, we want to know where is the mean. It is always at the center, which is the mu. If you're going to go to the right side, to add the standard deviation plus standard deviation and another standard deviation, then you have your values on the x-axis. And on the other side will be a subtraction. And the formula in solving for the z-score is you have there the score minus the mu or the mean and the small sigma, which is your population standard deviation. Now let's have some understanding how are we going to solve for the actual area, or how we're going to determine the actual area. I have here the bell-shaped curve. As we recall, if it is z is equal to 0, it is on the center. On the right side are +1, +2, +3. On the left side is -1, -2, and -3. Now let's have example number 1. Find the area from 0 to 1.25. So we write here 0 and 1.25. I have here a simple formula. It is as simple as adding the two value and getting the absolute value since we're talking here of the actual area. Now, the area of 0 is 0. The area of z is 1.25. Let's check on the table. It's 1. Let's copy. And the actual area is 0.3944. Now, the second example, it is from 0 to the left side, which is -1.25. We will have the same area since they have the same value, even though it is a negative. Let's have the third example. Let's erase this first. Now, please check the statement here. Find the area to the left of z is equal to 2.0. If you hear the word to the left, meaning to say it is synonymous to the word in the problem set, decrease or less than. But it is on the right side, in the problem set, we will hear the word more than or increase. Now let's solve number 3. It is 2.0 to the left. Now let's check here. It is 2.0 and the direction is going to the left side, meaning we're going to cover the entire left side. Let's have first the actual area of 2.0. And from 0 to 2.0, the area is 0.4772. Since we're going to cover the entire left side, we're going to add 0.5. And the area now to the left of 2.0 is 0.9772. And for the fourth example, it will be the same, because if it is on the left side, which is negative, and the direction is on the right side, therefore, we will have the same area. Let's have example number 5. Now, check the statement. It is to the right of 1.52. So therefore, we will have here 1.5 somewhere here. And it is on the right side. So meaning to say, if you're going to use a paper and pen, you're going to shade going to the right side. So let's write first 1.52. Let's erase this. (1.52), 1.5, and here 1.52. Now, the actual area from 0 to 1.52 is 0.4357. Since we're talking here of going to the right side from this point, we have to subtract by 0.5. Why? Because we're going to get only the values going to the right. Please recall the total area from 0 to the right side is 0.5. So therefore, you're going to get the extreme right side, you have to subtract 0.5. Now, if it is on the second example or next example, it is negative 1.52, but it is to the left. So meaning to say, you have here 1.52 going to the left side. Now, you will have the same area. Why? You're going to get the extreme left side values or the extreme left side area. Now, let's have this example. How about if the area now is 1.25 to 2.5? So let's write here 1.25, 2.5. Let's erase this. Now, 1.25 is somewhere here, and 2.5 is somewhere here. Let's get first the value of 1.25 here, and 2.5. So thus the answer is correct. What do you think? The answer is wrong. Why? The shaded region, if you're going to plot 1.25 here and 2.5 here, therefore the shaded region will be like this. So meaning to say we're going to get the middle value. So what are we going to do? We're going to change our formula, which is subtraction. Therefore, this will be now the actual area. Now, let's have the last example, which is negative 2.25 to 1.5. So let's erase this first. So 2.25 to 1.5. Let's get the area. 2.25, 2.25, this one. And 1.5 is on this one. Let's pay. Question. Are we going to add or going to subtract? Now, let's locate here to understand this further. 2.25 is somewhere here, which is a negative. And 1.5 is on the right side. So meaning to say, we're going to shade this one we can see a larger shaded region. So what are we going to do? We're going to add the two values. And that's how we're going to locate now the actual area under the. Now, let's solve this using Excel. As you can see how we're going to plot the points. Please recall that the average or the mean is 100 and it is on the center. Now, if you're going to get the values to the right, you add plus standard deviation, which is 10. So we'll have 110, 120, and 130. And on the left, we subtract 10. You will have minus 100, minus 2, standard deviation, which is 80. And you will have here 70. Now, let's solve for the probability, which is 100 pesos to 110. I have here my formula. So using the formula, you subtract the value, which is the score. You have the mean and the standard deviation. So I have subtract the standard score minus the mean divided by standard deviation. So this becomes now the value of your z. Let's put 100, the score of the first given, the mean, and the standard deviation. And on the right side, as you can see, this is the actual score. So how do I do this? This is the formula. I get the normal distribution, which is your score, which is your mean, your standard deviation, and this cumulative frequency, which is true. Then I get the absolute value. Now the probability is 0. And for the second given, 110, the mean, and the standard deviation. So therefore, I have here the z-score of 1. And based on our table, it is 34.13. Therefore, the probability of having a score from 100 to 110 is 34.13%. Now, to see the actual graph, I have here another downloaded formula. I'm solving for the actual graph. This is the minimum value and the maximum value. And this will be now the actual graph of the given from 100 to 110. Erase this first for the next example. For the second example, we have here from 110 to 130. So we're going to get the probability. 110, 100 as the mean, 10 as the standard deviation, same with this. So therefore, what are we going to do now if we have now the actual area, which is 34.13%, if it is 1, and the value of the z for 130 is 3, it is 49.87. How come we have here 15.73? To understand this, let's graph. So from 110 to 130. Now you can see the graph, it is on the right side. So I mean to say, it is from 130 and from 110, it is on the middle. Now, what are we going to do? We're going to subtract the two given probability, which is 15.73, which is the actual probability of having an allowance of 110 to 130. Now, let's have the third example. Now, the allowance from 80 to 90, what is a probability? Let's put the values in our formula. Same with this. Now, as you can see, we have here a negative 2. The actual area or probability is 47.72, is from 80, and from 90, the probability is 34.13. So what are we going to do here? Same with the second example. We're going to subtract y. Let's put the value here. as the minimum. As you can see, it is on the middle. So what we're going to do, we're going to subtract the two probabilities for us to get the actual probability. Now, meaning to say, the number of students or the probability of students who's having allowance of 80 to 90 pesos is 13.59%. Let's go with the second example. Now, suppose we're going to get greater than or equal to 115. Let's erase this first. First is 115. If you're going to place 115, it is on the right side, going to the right. Why? Based on this statement, it is greater than 115. Now, let's solve example number 4. Now, suppose we're going to get now the number of students whose daily allowance are greater than or equal to 115. Now, we're going to look at it when you say greater than, so from the mean of 100, and if, for example, this is your 115, this is going to the right side. So let's put our values here, score, the mean, and the standard deviation. Since it is on the right side, what are we going to do? We're going to make a new statement of 115. So what are we going to do here? We're going to subtract 0.5 with the area of z-score 1.5, which is subtracting from the area. And therefore, the probability of having an allowance greater than or equal to 115 is 6.68%. Since we're talking here, we're going to get the number of students. So what are we going to do? We're going to multiply the probability of greater than or equal to 115. Therefore, we will have 3.3 students. Since we do not have half students, so we are going to round this off. So therefore, there are 3 students whose allowance is greater than 250. Now, what will be now the actual graph? So it is 115. So therefore, let's check. Since we're going to the right side, so it compensates. If the shaded region is lesser, therefore the probability is lesser and also the number of students. Let's go with number 5. For example, number 5, let's move this first to solve for the next one. Since we're talking here of the allowance from 75 to 118, so I already encode this. So what are you going to do? Place all the values in our table. So the z-score of 75 is negative 2.5, and the z-score of 118 is 1.8. So this becomes now the actual probability or area. So what are we going to do? So let's graph for us to understand. It is 75 to 118. As you can see, it is on the middle. Thus, our answer is correct. The answer is wrong. Why? Look at the shaded area. It is larger. And the result is quite smaller. So what are we going to do? We change this to addition. So we add the two probability. Therefore, the actual probability of student having allowance of 75 to 118 is 95.79%. Since we're dealing here of getting the actual number of students, so we multiply the given probability by 50, multiply by 50. So therefore, we'll have 47, or we can say this 48 students. Okay? Now, let's solve for number 6. Now, greater than or equal to 85. So I already encode this one. So we have here 85 as the standard value or the score. We have the mean and the standard deviation. You just place it in the table. The probability of the z is 1.5. Then what will be now the actual? It is 43.32. How are we going to solve for the actual probability? Since we're talking here of greater than to 85 or greater than or equal to 85, what are we going to do? We're going to add 0.5 to the probability because it is from 85 and 85 is on the left side of the average. Now let's put the value here. Now, so as you can see, our given, it is from 85 going to the right side. So therefore, we have a larger area covering the other half, and the number of students will be 46.65 or 47 students. Now let's have the last example. It is less than, let me remove this first. It is less than to 113. Then when we say less than, you're going to the left side. So let's place the value here. Mean, the standard deviation. So from the average going to 113 is 40.32. Now since we're going to cover from 113 going to the left side is less than, we're going to add 0.5. And therefore, this is the actual probability. To get the number of students, you have to multiply this by 50. So therefore, the number of students whose allowance is less than 113, we have here 45 students. For the actual graph, we have here 115. As you can see on our graph, it is from 115 going to the left side. So that's how you solve now for the normal distribution. And I hope you learned something from our video presentation.